So, Namashivaya, this is our reinforcement learning project. Our group number is 12. Our project is reinforcement learning for Flappy Bird in JS. These are our group members. Coming to the next slide. So, firstly, we will see the intro of the project. As you all know, Flappy Bird is a game where a player controls a bird attempting to fly between columns of green piles without hitting them. In this project, we tried to explain how RL works in a simple way by training a game of Flappy Bird using Q learning through a script in JavaScript. So, what is a RL? It is an area of machine learning in which it deals with how agents must behave in an environment. The agent is given a reward for achieving its outcome and penalty for taking the wrong decisions. So as the time passes, the agent learns to take actions that maximize its rewards. This area of ML is used in variety of fields. They include robotics, games such as Flappy Bird, finance, and also in healthcare. So what is Q-learning? Q-learning is a model-free reinforcement learning algorithm to learn the value of an action in a particular state. So it does not require a model of environment, hence it is model-free and it can handle problems with stochastic transitions and rewards without requiring adaptations. It can identify an optimal action selection policy for any given FMDP, given infinite exposition time and a partly random policy. The Q refers to the function of the algorithm that expected rewards for an action taken in it. So the rewards. The reward values are assigned in the reward the word function based on the performance of the Flappy Bird. It takes two parameters, reward and was successful. Reward represents the amount of reward to be given to the Flappy Bird for the successful output, and was successful is a boolean value indicating whether the episode was completed successfully or not. If the bird was above the ideal passage position and it chooses to jump, it is negatively reward as it may hit the green columns. Similarly, if the bird is below the ideal passage and it chooses to stay in the same passage, it is also given negatively rewarded. Otherwise, the reward is set to a positive value of 0.5, which reads to the passage of the green column. So the Q value for a state action pair is updated using the Q learning algorithm, where the update value is calculated based on the discounted future rewards and the current Q value. So these action and states. The agent performs two actions, mainly jump and stay. Whether the bird has to jump to pass it or to stay to pass the green columns. So the different states of agent are represented by following parameters. So as you can see, speed will represent the speed of Flappy Bird in y-axis. Tube x represent the x coordinate of next incoming tube. Differ y, the difference between the y coordinate of the bird and the y coordinate of ideal passage position between two tubes.
Sure, I'm Srivastav from AI Batch. Today I'll be explaining regarding Q learning algorithm. So there are 5 steps in this Q learning algorithm. The first one is initializing the Q table, then choosing an action, then perform the action, measure the reward, and last let's update the Q table. So these iterations will be done multiple times until a perfect and good Q table is ready. Coming to the next one, it is the training the agent. So Q-learning is a reinforcement learning algorithm that works in a similar way that the agent starts by playing a random game at each particular game. So the agent will try to figure out each and every value of the Q table and updates the table in according to a good action. So which is a measure of how the action is when compared to the state. So the agent learns to take actions that lead to higher Q values, which in turn lead to higher rewards. So as the agent plays more games, it learns to take the actions that lead to a higher reward and more consistently. This is because the agent is constantly updating the values of Q table and based on the experience. The more experience the agent gains, the better the reward of the game will be. This is why, because the Q learning is a powerful reinforcement learning algorithm that can be used to learn to play a variety of games in a model-free algorithm, which means that it does not need anything or any rule in order to play the game. It just learns the game by itself. This makes it a very versatile algorithm that can be used in any reinforcement learning problems. So coming to the next one, so here we have used two equations. The first one is Bellman equation, and the second one we use the Bellman equation to update the Q table, which is Q update rule. So this is the above equation, and the below one is the Q learning table. Uh, in order to say, Bellman equation is the value of a state which is equal to the reward of the agent receives for taking a particular action in the state, plus the discounted value of the next state. The Q rule says the Q value for a action state action pair, and should be updating by adding the differences between the actual reward and the predicted reward. This will be done multiple times in order to gain the learning rate. So the Bellman equation with and the Q update rule both are very important equations in reinforcement learning. These are mainly used in reinforcement learning algorithms to learn and understand how the environment is in the game. The agent will be able to play Flappy Bird game at a trained data, and it can be learned by using the given data in the data set. So here the agent will learn to control the bird in order to avoid the pipes and increase the score. The agent will be able to do this in the reinforcement learning environment, which is a type of machine learning environment which allows an agent to learn how to behave in an environment to in order to get a maximum reward. In this case, the Flappy Bird, the agent is trying to get the maximum reward points by avoiding the pipes in the way. So the agent learned how to play Flappy Bird by playing the game over and over. Each time of playing the game, it receives a reward for each point. So the agent would then use to gain the reward in the queue table, and it updates each and every step so that the agent gets the maximum reward. After playing this game multiple times, the agent's queue table will be very accurate, that this would allow the agent to make the best possible decisions in order to control the bird to avoid any pipes and increase the score. So in the result, the agent would be able to play the flapper at a higher level and score over easily 100 points in a single game. Conclusion, I would say, Flappy Bird, in this case the agent is bird and the environment itself is game. So the agent's goal is to fly between the pipes without hitting them, and so that the agent will be doing nothing but flap or do nothing. So the agent state is defined by the distance of the upcoming pipes and the distance to the ground and the bird's velocity. So this is the presentation. Thank you.
Hello friends. So now I'll be showing you an implementation of the code for the Flappy Bird game. So our game has been implemented using the Q-learning algorithm, which was earlier explained by my friends. So there are two actions that the particular agent can take. One is stay and the other one is jump, which is defined over here using the action set object. And the different states are being defined using three different parameters. So one is speed y, so it determines the speed of the Flappy Bird in the y-axis. TubeX is another parameter it depends upon, which is the x-coordinate of the incoming tube. And last but not least, def y, which where we define the ideal position from which the Flappy Bird should pass through the very middle of the vertical spaces between the two tubes. So we have also defined other parameters for our Q-learning model. So one of them is our discounted rewards, and the other parameter is alpha, which is our learning rate. So discount factor is used for determining the importance of the future reward. And we have also defined other certain objects, and another important object was trials, which maintains the count of number of trials. This function over here, which is getQ, it takes in two arguments. One is state and the other one is action. So this function is used for looking up the estimated Q value from the Q table for a given state action pair. The getAction function takes in one argument, which is state, and this function is responsible for selecting the appropriate action corresponding to the given state. And the action which has a higher Q value for a given state is usually what is executed by the particular agent. This is the part of the code where the agent will look up the Q table and currently choose the different actions corresponding to the rewards for that particular given state. This function, which is the reward the bird function, will determine what reward is supposed to be given to the agent based on the action it has taken. There are different cases where the agent can sometimes jump through the particular space between the green tubes when it already can pass in without jumping, and there are certain cases where the bird can decide to stay when it is supposed to actually jump through the spaces. So that is being defined in this particular over here. So over here, this is a loop which we have defined. So if the particular bird was above the ideal passage position and it still decides to jump, you are supposed to reward the agent with a negative reward value. And in other cases, we reward the particular agent with a negative reward value if the bird was below the ideal passage position and it still decides to not jump. Otherwise, in other cases, we actually provide a positive reward for the agent for taking the right decisions. We'll update the Q value for a given state action pair according to the algorithm Q learning. So this is the line of code which will update the Q value based on the parameters which we already have, which is alpha into reward for state plus gamma into optimal future value minus Q value for the particular state given that a particular action has been taken. We have a function which will trigger the game over message. So once the game is over, the bird will be rewarded with a negative reward and set the whole game back to 0. Other certain objects which we have defined over here. One is querying the Q table to determine the appropriate action to be taken for the current state. So now we have gone through the proper implementation of our code over here. So now we'll be moving on to the game demonstration, which is here. Yes, that's good. Before I actually start playing this game, I'm gonna load the model from my local storage. So now I can actually start playing the game right now. So initially the agent was not responsive and it was taking decisions on its own based on the reward that it was receiving. So as you play the game a lot more, the agent will learn to take decisions more wisely and not more hastily. There are two different types of environments that I have actually defined over here. So one is the static environment, where the position of the gap between the two green tubes is almost similar and doesn't change. And there's also a random environment where the gap between two green tubes will be more random. Generally, whenever I am moving in a static environment, it would take the agent a mere 25 trials to actually get a hang of the environment, whereas in a random environment, it would actually take close to around 1,000 trials to get get used to the environment it's been deployed in. The highest score, in my case, my high score was 10. So there are cases where my agent would actually jump twice when it's not supposed to, but it's okay if your model is initially doing something like that where it takes actions on its own, because that's what reinforcement learning is all about, where it has to learn through its experiences. As time goes on, the agent will learn to take decisions more properly. It will actually not take decisions on its own. So yeah, as you can see over here, the I've taken 37 trials as of now. Agent is actually start to take decisions much more wisely. And as you can see here, the bird is actually, or my agent in this case, is not taking the wrong decisions in most of the cases. That concludes our project over here. Thank you so much.